Assalamualaikum warahmatullahi wabarakatuh. Okay, for the introduction, because it is one of the faster and cheapest technique of determining shear strength, the unconfined compression test is by far the most prevalent method of soil shear testing. The technique is typically utilized to recover saturated, cohesive soils from thin wall sample tube. For dry sands or crumbly clay, the unconfined compression test is ineffective because the material will crumble in the was no lateral confinement. Okay, the next slide. Okay, for the next slide is a theory of study. The unconfined compressive strength is the load per unit area at which cohesive soil cylindrical specimen is compressed. So this is a formula U per P per A, where P is the load at failure, A corrected area. Okay, so we can get AO per 1 minus E, where AO is the initial area of the specimen, E as the strength, and change in length, original length. The undrained shear strength as of the soil is equal to the 1/2 of the unconfined compressive strength.
Methodology. This experiment to determine the soil under unconfined condition. According to the ASTM standard, the unconfined compressive strength is defined as the compressive stress at which an unconfined cylindrical specimen of soil will fail in a simple compression test. The most critical condition for the soil usually happen immediately after construction. This experiment can be calculated by find the initial area of specimen and follow other steps where can be expressed as initial area of specimen, change in length of deformation, axial strain, load, corrected area, and stress. After calculating, the graph of stress versus strain was sketched carefully and shown on the datasheet. Draw more circle using QU from the last step and show the undrained shear strength. For the apparatus, we use unconfined compression load frame, deformation die gauge, mold, weighing balance, stopwatch, sample trimming equipment, and grace.
We will first need to obtain our sample. Typically, this is an undisturbed sample of cohesive material that was obtained using a dry rig and Shelby tube sampler. The sample comes from various steps depending on the soil profile of the site. The Shelby tube allows us to get an undisturbed sample and maintain our in situ moisture content. The sample will come back to the lab to be locked in. We will use sample that was called out from the engineering test program. For our test, the Shelby tube will be placed in an extruder to remove the sample from the tube. Once the sample has been extruded from the tube, we will lock in and pick the area we want to run our test on. We are looking for sample that is cohesive, homogeneous, and 100% saturated. The sample should be between 2 and 2.5 to 1 ratio. Anything that's shorter than a 2 to 1 ratio may give us additional strength due to the end effect, and any longer may introduce a buckling force. The sample will be cut out, making sure that the two ends are parallel to each other and perpendicular to length. Once we determine what we are going to use for a sample, we will put in our trimming machine and trim off the excess amount. After that, we will measure the length and the diameter, also get weight on the sample.
Then, we will take a moisture sample from the end cuttings and place them in the oven. And then, place our sample in our testing machine. We will want to run this test as soon as possible after we have extruded the sample to prevent it from drying out and gaining additional strength. Okay, let's start our test. The first thing we need to do is to determine a displacement rate. Because it is an unconfined sample and we are not worried about pore pressure building up, we can shear it at what is considered a rapid rate. This rate is determined by the length of the sample. Rapid means we can shear it at 0.02 inch per minute per inch of the length of the sample. So, if we have a 5-inch sample, our shear rate will be 0.1 inch per minute, which will allow us to shear our sample between 5 and 50 minutes. We will go ahead and start our test and watch out our graph and sample. The test will be run until we reach and pass the maximum load on our load displacement curve. As we look at the sample, we will see the shear plane developing. If it meets all of the criteria talked about previously, then we should see a 45-degree failure plane. Once our test is complete, we will remove it and take pictures of our shear sample. The data set will be given to you to analyze.
Hi, my name is Michelle Shana Bidazlan. I want to present Chapter 4 Data Analysis and Result. The data analysis, sample data, diameter, length and mass. Moisture content determination, test number 1, T number A, mass of MTK 15.6, mass of can and wet soil 45.7, mass of can plus dry soil 39.5, mass of water 6.2, mass of dry soil 23.9, moisture content 25.94. The calculation got area and volume. Area 41.74, volume 616.9. Moisture content determination, the calculation we got, we have done wet density. Wet density we got 1.98, water content 25.9%, dry density 1.57 gram cm. Unconfined compression determination, sample data, diameter, length and mass. So this is the experiment result. The deformation reading we have done until 3000.
That's all from me, thank you.
So for the next slide, I would like to present about the discussion and the result for this experiment. Based on the data that we have obtained earlier, we will get two graphs for this experiment. For the left side, you can see the graph of axial stress versus axial strain. When we get 15% of axial strain, then this will resulting that we will get 72 kPa for axial stress. While on your right side, you can see the more circle graph for normal stress versus shear stress. Based on this graph, we can see that we get the cohesion is 36 kPa and 72 kPa for the unconfined compression strength. So based on the result that we get from the stress strain curve and the Mohr circle, we can get that the unconfined compression stress QU is 72 kPa, while the cohesion C is 36 kPa.
For the conclusion, the unconfined compression test is one of several techniques for the assessing soil shear strength. It is important because it's a quick test for evaluating the shear strength parameter of cohesion soil, whether disturbed or removed. The test is strain controlled and the pure pressure shift as the soil sample is added quickly. This test is accurate, however it cannot be used on the soil with low cohesion or the coarse grain. Shear strength is influenced by a variety of the other factors in real-world situation. By the way, for the water drainage, compaction strength, direction and rate and particle density are the considerations for estimation. Other tests such as the Uthm test or the pocket parameter test can be used.